Also, we have seen the evaluation algorithm. We have seen different applications where stack data structure is used, and we have started discussing one of the application which is expression conversion and evaluation using stack. So yesterday we saw the algorithms for evaluation of postfix and prefix and why it is simple for solving for the machines. Okay, because it is free from parentheses and the precedence it need not be considered because while converting the precedence is taken into consideration. Okay. So today we are going to see the conversion algorithms, expression conversion algorithm. Any problem up to now in evaluation? Yes. Shall we go for conversion? How these postfix and prefix expressions are formed? Please respond. Okay. Are you asking about evaluation of postfix and prefix? Postfix expression, it is evaluated by uh, accessing the postfix string from left to right, whereas prefix will be evaluated by accessing it from right to left. Okay, we access the prefix from right to left, and in postfix evaluation, whatever see we pop when operator comes, and in postfix, first popped is operand 2. Okay, it is the second operator, and secondly popped value it is operand number 1. So operation is done between operand 1 and operand 2 and in between the operator. Okay, whereas in prefix the first popped is operand 1. Okay, as we are moving from right to left, so first popped will be operand 1 and second pop will be operand 2, and then operation will be done between operand 1 operator operand 2. Okay, so these are the two differences. Is it clear? Shall we go for conversion? How these postfix and prefix expressions are formed? So if the subtraction in prefix we do, yes, even if yes, in postfix also the operation is op1 operator op2. Okay, but in postfix op2 is first retrieved from the stack and op1 is next retrieved, next popped. Whereas in prefix op1 will be first popped and second popped is op2. Okay. Yes. So we'll go for the conversion algorithms now. So we have to see infix to postfix conversion and infix to prefix conversion. Now the infix expression uh, it will contain the parenthesis as well as we need to consider the precedence. Okay, so along with the operand and operator, in the infix expression we will have the opening bracket, closing bracket. Okay, so we will access the expression, infix expression again from left to right while converting it into postfix format, and we will now come across operand, operator, opening bracket or closing bracket, and also we need to consider the precedence of the operator. Okay, So when we want to convert expression, the most important thing we should know is precedence of the operators. Okay, because with the precedence, the expression will differ. This helps in determining the order of evaluation of operands. Okay, so at the time of evaluation, the precedence matters. That's why we need to consider the precedence while converting. So if these are the infix expressions, we should know what is the suitable postfix for it. This dollar sign is for power here. Dollar sign, it indicates power. Okay. So a plus b, it is simple. Its postfix is ab plus. Here in a plus b minus c, we can have ab plus c minus, or the algorithm which we are going to use, it will say abc minus plus, like this. Okay. Then in this case we have the brackets, so ab plus cd minus into. Okay. So we have seen how these expressions are formed. Now we'll go for the algorithm. The rules for converting infix to postfix: the expression is accessed from left to right. Then read one character at a time from infix expression. Make use of stack to store operators. So our stack should be now character stack. Okay, we have to use object of the character stack now, because we will be storing operators. We will be holding operators until its respective operand is found. There should not be any parenthesis in the postfix form. So in infix we will have the parenthesis, but in postfix we need not take any bracket, any parenthesis. This is the logic for infix to postfix. So if we come across operand, now again we are accessing the infix from left to right, and we are checking the current character. What is that current character? If it is operand, add it to the postfix expression, that is output. We will copy it as it is into the required output string. Now our output here is postfix string. Okay, we are converting infix to postfix. So both are the strings. Input expression, it is infix, it is string, and output, it is also a string, which is postfix. So if it is operand, we will copy it directly into the output string, then closing parenthesis, then it will indicate, it will tell us to pop the stack symbols until an opening parenthesis is retrieved, it is popped. Okay, then just see the conditions now. We will solve some example for this, and then we will come back to the algorithm. Then if it is operator, what we have to do? Operator hai to you have to you have an uh, on stack and off stack precedence. Pop all stack symbols until a symbol of lower precedence appears. Okay, so we have to compare the precedence of the operators now. If the operator comes, we have to compare the precedence of the operator with the uh, topmost operator's precedence. Okay, and we have to pop all the stack symbols, that is all the operators, until a symbol of lower precedence appears. Okay, so all higher precedence operators we will pop and copy into the postfix expression, and then push the current operator onto the stack. And at the end of input, pop all the remaining stack symbols and add to the expression. Okay, and one more condition is, if it is opening bracket, you have to push that also into the stack. Okay, with this we can go for looking at one of the examples. So suppose now we have to convert this infix expression into the postfix format. This is the infix expression which we need to convert into postfix. So now in our expression we will go from left to right, and this is the token, this is the postfix which is initially empty, this is the required output, and we will take help of stack. Okay. Stack is also initially empty. Now current character is A, the postfix is initially empty. We will copy the current character, it is operand, that's why we will copy it as it is into the postfix expression. Okay. The next is minus, which is operator, and in case of operator we have to compare the precedence with the current element into the stack, current topmost operator into the stack, but it is not there, it is stack is empty, that's why we will have A as it is here, and minus will be pushed into the stack. Our stack is growing from left to right. Okay, so minus is into the stack now as it is operator. Then comes B, it is a token, so it will have AB, and this will be minus as it. Then multiplication. Okay, multiplication is there. This is AB, and now multiplication and minus, the precedence will be compared because top is currently pointing to this minus operator. So precedence will be compared of multiplication and this minus sign. Right? So which precedence is more? Is top pointing to higher precedence operation or no? Top is not pointing higher precedence operation, isn't it? Are you getting? Multiplication will have higher precedence subtraction. That's why when precedence of multiplication and minus is compared, it is observed that it is already minus is already a lower precedence operation. So my this multiplication will be pushed as it is into the stack. Okay. Then go ahead. This is the next. Go ahead. Next character here is C. Okay, next token is C. So it is operand will be directly copied into the postfix, and this will be as it is minus into. So its next character is opening bracket. Opening bracket is pushed into the stack. Okay, opening bracket it will be pushed into the stack. Then B will be B. Oh, we have minus. We have missed minus one. There is one minus remaining. After C, there is minus token which we have skipped. So minus. Now, when minus comes, the precedence will be compared of minus and this multiplication, the topmost element in the stack. And in the stack, we have higher precedence operator. So it will be popped and it will be copied into the postfix. Okay, higher precedence operator will be popped and it will be copied into postfix, and then uh, yes, then minus again next element in the stack is minus. So minus and minus are having same precedence. Current operator is minus, and in the stack also we have minus. So in some books it is given like equal uh, equal precedence operators are popped. Okay, in some books it is given like that, but I will see what we are going to do is the book which we are referring for is it from that we will follow the algorithm which is given in your book also. So if it is equal precedence operator, then I'll just check. Okay, so if it is greater, then only we are going to pop. So equal precedence operators will be pushed. So both will be minus will be there. Okay. Then opening bracket. When opening bracket is there, you have to push it into the stack. Then comes D. It will be copied into the stack, uh, into the postfix as it is because it is operand. Then minus, again minus will be pushed into the stack. See, if there is bracket, no need of comparing with other. Okay, so minus will be directly copied. Opening bracket है तो compare this opening bracket will have the precedence higher than every operator. Opening bracket will have higher precedence than every operator. Sorry, the lower precedence than every operator here. Okay, that's why minus will be pushed. I'll show you that precedences, what values you have to design for precedences. Then E, it is operand, so we will copy it into the postfix and stack will be as it is. Then closing bracket, when closing bracket comes, you need to pop until the respective opening bracket comes. Okay. So you have to pop from the stack and copy into postfix. So minus will be popped and it will be copied into postfix. The next pop is opening bracket. So we will stop popping. When opening bracket comes, we will stop popping. So again in the stack we have minus minus. Then comes divide. Divide. So the comparison will be done between divide and minus, and divide is having higher precedence. So it will be minus minus divide. F will be copied into the postfix. And now we have reached slash 0. Okay, end of the infix. So we will start popping now everything from the stack and appending into the postfix. Divide minus minus. This divide will be popped, will be copied, then minus, then minus. Okay. So we'll see whatever we have calculated manually. This expression it is same like what our algorithm is giving us. ABC into DE minus F divide minus minus. Clear? The algorithm is clear. What conditions we have followed? If the current token it is operand, we are copying it as it is into the stack. If it is operator, then we need to compare the precedence with the topmost elements precedence, and all higher precedence elements we have to pop and then push the current operator onto the stack. Then if it is opening bracket, we are pushing into the stack. If it is closing bracket, we are popping from the stack until opening bracket comes. Okay, so these are the conditions based on which you have to uh, decide what you will be taking action for the current token. Okay, and accordingly you will be converting infix to postfix. Is the algorithm clear? Is the logic clear? Shall we go ahead? Yes, shall we go ahead? See, you have to implement these conversion algorithms in your assignment along with the evaluation of postfix and prefix. So make sure that you have understood the algorithms so that you can write these conditions. Okay. So in detail, we'll see the algorithm to convert infix to postfix. Read the expression from left to right. If the character current symbol in the input string is operand, then print it in the output string, that is copy it into postfix. If it is opening bracket, push it onto the stack. If ch is the first operator or first operator after opening bracket, then push it onto the stack. Okay? So after opening bracket means when you are popping and you come across opening bracket, you need not uh, see what is the precedence of the operation for opening bracket. If priority of ch, that is current operator, it is less than or equal to that of element on the top of the stack, then pop the top element and push ch onto the stack. Okay, we will not pop the equal priority operator. Will not pop the equal precedence operator. But in some books, this logic is popped. Okay, so we will go with the Furuzen logic. If priority of ch is greater than that of top element, then push the ch on the stack. At the end of the input string, pop all the entries from the stack till it becomes empty and write them into the output string. If CHA is closing bracket, then pop all the entries from the stack and add them into the output string until you encounter opening bracket. Okay, so one by one we'll see certain examples here. So you have to design a table like this, okay, in order to solve such examples. And I want similar examples. Okay, not so simple. Here the conditions for bracket is not there. Okay, I want a proper example to be solved in your write-up for all this. Okay, using these tables. So you have to take one by one token and you have to decide here. Here dollar is /0 for /0. Okay, so here when you come across higher precedence operator multiplication, you are popping that higher precedence operator and then pushing the current operator plus into the stack. Okay, with this you will solve the example. In this example, your dollar is power. Let's say for power. A minus b divide one by one. A, 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 B, and minus will be the stack. This operator, the precedence will be compared. If the divide is having higher precedence, it will be directly pushed. Power is having higher precedence than multiplication, so power will be also directly pushed over it. Like this, the conversion will take place. So this will be the precedence function, which will check the precedence value. So in stack precedence and out stack precedence. In stack means when you are inserting into the stack, and at the time of popping you have to check this out stack precedence. Okay, at the time of pushing you will be seeing accessing this in stack precedence. So if it is opening bracket, return 0 means if you are pushing any operator and you are comparing the precedence with this opening bracket, then its precedence should be lowest. Okay. Power will have highest precedence. All other things are like this. Okay, these are the values which we have decided. It is not exactly like 5, 4, 2 like that. You can have any sequence of this. But this should be higher. Power should have highest precedence, then multiplication, divide, and percent that they will have the lower precedence than power and higher precedence than plus minus. Okay, plus minus will have lowest precedence, otherwise written 3. And out stack precedence is when you are popping out. Okay, so for this, we'll see the example of this one PDF I will share, okay, in which these precedences are used. They have told why we are taking this precedence. So while popping, the highest precedence, this again power is having highest precedence is looking, but for opening bracket it is the precedence high 100, the highest one. Others are similar, but for opening bracket it is the highest. Again, certain examples. So I want that you should solve certain examples like this. I will share an assignment for this on the Google Classroom, which you can include in the write-up. Okay, certain examples, because until and unless you are able to solve on paper, you will not be able to write the algorithm for that. Okay, so this is the algorithm. Take as which is stack contains operator. In length you have, okay, this is for prefix. But first we'll see the code of postfix explain. Infix to postfix, that code we will see. Then we will see what changes we need to make for in the prefix conversion. Evaluation we have discussed. For evaluation we need the calculate function, which takes two operands and one operator and returns the result. And for conversion, we need the precedence function. So see here, precedence. And so this is actually not used because we are not going to consider here. It will automatically return 0 for opening bracket. Okay, because it is not, opening bracket is not under these operators and these operators. So it will automatically return 0 for, that is lowest precedence for the opening bracket. So we have taken infix expression from the user. Okay, enter the expression of infix form, and then we will call this convert into postfix function. Okay. In the main function, with the main function, see, first of all we have created object of this expression, and in this constructor only we have taken infix expression from the user. So directly convert into post. This is the first expression which we will be doing. And the same algorithm which we saw, that will be executed here. So for I equal to 0 to string length of infix I plus plus. Okay, so we are accessing now expression from left to right. I equal to 0, I is the index of the current string. I equal to 0 to string length of infix. We are now accessing infix. So current character, it is element. Element is equal to infix of I. Okay, current character is element, which is infix of I. And then we are now checking whether it is operand or not. So this condition, as we have seen yesterday also, is unknown of element not equal to 0. This is the condition which is telling operand, whether the current element is operand or not. So if it is operand, we have to copy it as it is into postfix expression. Okay, so postfix of j plus plus is equal to infix of I. J is initially 0. Okay, so postfix of j plus plus, it is infix of I. Clear? And postfix is also a member of class expression. This infix, postfix, prefix, these are the strings which are declared in the expression class. And also a stack object is created, STK, which we can use here. Actually, stack you can declare here in the convert function, so that it will be initialized properly. Instead of creating the object, stack object here, we can create it in the local convert function. So as well as this convert function. So stack object we will need, where we will be storing the operators now, and this stack is character stack, which is storing character data. Okay. So if it is not operand, first condition is we are checking operand. Operand has to copy directly into postfix. Then go ahead, check whether it is opening bracket or not. Okay. If it is opening bracket, we are pushing that directly into the stack. We will push that element into the stack directly. If it is closing bracket, then we have to pop and copy into postfix string until the opening bracket comes. So while stk.talkStack is not opening bracket, you have to pop from the stack and copy into postfix. And if it is opening bracket, then it will be just neglected. Opening bracket will be just okay. So while stack.talkStack, it is not opening bracket, popping and copying into the postfix string. Otherwise, while precedence of element, it is less than precedence of top stack. See, when it is not operand, okay, it is not operand, it is not opening bracket, it is not closing bracket. That means it is operator. Okay, if it is operator, then you have to compare the precedence. So we are comparing the precedence of current element with the precedence of top stack. Okay, the current top element in the stack. We are comparing it. So if current token is less precedence, okay, that means in the stack we have all higher precedence operator. Then we are popping those higher precedence operator. Okay, so in the stack we have higher precedence operator and stack is not empty. Then we are popping. Then we are popping all the higher precedence operators from the stack and we are copying it into the postfix. Okay, except opening and closing bracket. Opening closing bracket we are not copying into the postfix. All other remaining characters or other remaining operators will be put, will be copied into postfix. And yes, we are pushing the current token, current operator onto the stack. After copying all higher precedence operators, we are copying, we are pushing the current operator into the stack. Okay. This loop is for popping all higher precedence operators. And then we will push the current element into the stack. Okay. And after we have performed this, if we come to the /0, that means end of the string, then we have to pop everything from the stack and copy it to the postfix. All remaining operators we have to pop and copy into the postfix. Okay. And finally append /0 in the postfix. I will execute the. Is the algorithm clear? Is the algorithm clear? I will execute the program. Enter the expression of infix form. You can give the same expression which we have solved. A minus B into C minus D minus E divided by F. Convert infix into post. We'll check the answer. Yes, it is same. ABC into DE minus F divide minus. Clear? The conversion algorithm is clear. Any doubt? You have to implement it in the next practical turn. This is, we have completed the postfix. Shall I discuss also the conversion into prefix format? So there is not big difference. Like there is not big difference in evaluation. Just 2-3 things are changing. Similarly here also in converting infix into prefix format, it will have certain few changes in the algorithm. algorithm for converting infix into prefix. We have to now access the string from right to left. Okay? Instead of left to right, we will be accessing the string from right to left. Then, if it is again, uh, we will have to do those certain changes. If it is closing bracket, then we will push into the stack. If it is opening bracket, then we will start popping. Okay? Otherwise, all those things are similar. If it is operand, then we will copy it into the prefix. If it is infix to prefix format, so scan character at a time from right to left, repeat until there is data. If it is closing bracket, we will push into the stack. If operand, okay, now see whatever final answer we are getting here, as we are accessing the expression from right to left, we need to reverse the final whatever expression we are getting. Okay, after reversing that, we will get the required prefix because we are getting the reverse expression. Okay, and after reversing that, we will get the actual prefix. So for that reversing, you can use either string reverse function or we can use the stack because reversing is one of the application of stack. So what we can do is we can store the temporary output which we are getting, that can be stored in the stack, and at the end when we pop from the stack, that will be our final prefix. Okay, so here in this particular algorithm we are using two stacks. One will be storing the operators like we have done in the uh, postfix conversion, and another stack will be used which is storing the prefix expression, and when we pop from this prefix expression stack, we will be getting the prefix. Okay, because we are get whatever expression we are getting at the end, that is reverse. Okay, so instead of storing it into string, we are storing that into the stack, and after copying everything from stack, we will be getting the prefix expression. Okay, so operands, instead of copying them into another string, we are copying the operands into the pre-stack. Okay, this pre-stack is used for storing that intermediate output. So if closing bracket, then we have to push it into the operator stack. If it is operand, we will be pushing the operands into pre-stack. Okay, if operator, then if stack is empty, push it into the stack, OP stack. Otherwise, repeat while precedence of top stack, it is okay, top of the stack. If it is having higher precedence or equal precedence than the current token, then we will be popping and pushing into the pre-stack. Okay, so this pre-stack is our intermediate output. So we are copying all the higher precedence operators from the stack and copying it into the pre-stack. Push the current and then push the current character onto the pre-stack. Okay. The algorithm is similar to the infix to postfix conversion. Only one change is here we are pushing the closing bracket, and when opening bracket comes, we will be popping all the characters from that stack, and we are copying that pop characters into the pre-stack. Okay, until opening bracket comes. So here there is difference, and one difference is we are using here two stacks because we need to reverse the output at the end. So pop and push to pre-stack until the stack is empty. Okay, so at the end of the expression, we will be popping everything from operator stack and popping into the pre-stack, and then pop and display the pre-stack. So that pre-stack will have our output, And after popping from that pre stack, we will have the actual prefix expression. Okay, so we are making here use of stack for reversal as well. Okay, otherwise what you can do is you can store it in another string, temporary string, which you can do the reverse at the end. You can reverse it at the end. That will be your output. So see here, if you want to convert this expression into prefix, you will be accessing from right to left. So if it is closing bracket, you will be pushing it into the OP stack. If it is opening bracket, you will be popping until you get the closing bracket. So closing bracket है तो push into the OP stack. Then operand will be in the prefix stack. Okay, that pre stack. Then minus, we are accessing now from right to left. Minus है तो you have to push it into the OP stack. Then closing bracket, again it will go into the pre stack. E, it will be in the pre stack. Okay. Then into, it will go into the OP stack. T, it will be in pre stack. Opening bracket, now you have to start popping until closing bracket comes. So multiplication will be popped. Then oh, closing bracket is accessed. That's why it will be neglected. Okay, so multiplication will be copied here after popping from here. Then again opening bracket comes, so you need to pop again. Minus will be popped, and its respective closing bracket is also popped. It will be neglected. Okay, so minus also is there in the pre stack, and now our stack is empty. OP stack is empty. Go ahead, multiplication, it will be pushed into the stack. Closing brackets will be pushed into the stack. Then C, it will be copied into pre stack. Divide, it will go into the OP stack. B into pre stack. Opening bracket, pop from the OP stack. Divide will be popped and it will be copied. Okay, and closing bracket comes, so we will stop. Now minus, it will be pushed into the stack. A will be in the pre stack. Opening bracket, pop until closing bracket comes. So minus will be popped, it will be copied. Okay, and finally whatever is remaining, as we have reached to the 0th character, whatever is remaining into the stack we have to copy it. Okay, that will be copied. So multiplication will be popped and it will be copied into pre stack. And finally from pre stack, prefix stack, everything will be popped and that will be our prefix. Okay, everything will be popped and copied into a string, which is a prefix string. So that's why we are getting the reversal of these elements into pre-stack. It will be the prefix required. Is infix to prefix conversion also clear? Is infix to prefix conversion also clear? Both the algorithms are clear to you. You need to solve certain examples in order to understand these algorithms. On paper, you solve multiple examples, okay, so that you can write the algorithm for it. And we'll see one functional test. As we have understood now what is the algorithm, we can see the code related to it. Convert into prefix. Here we are first finding the trend, and now we have these two stacks, pre-stack and OP stack. Okay. Now we are accessing the infix expression from right to left, length minus 1 to 0. Okay, so element is infix of I, current token, and if it is closing bracket, then push it into the stack. Closing bracket will be pushed into the stack. Opening bracket, then until closing bracket comes, we have to pop and uh, copy into the pre-stack. Okay, except the opening bracket. So all the elements will be pushed into the stack. Then if it is operand, this condition is for operand. Operand है तो we will copy into pre-stack. Okay. Otherwise it is operator. So if it is operator, we are comparing the precedence, its precedence with precedence of the top element in the OP stack. So if OP stack contains higher precedence operators than the current element, then those will be popped, and those will be copied into pre-stack. Okay? Higher precedence operators, after popping, they will be pushed into the pre-stack. And there is loop because we have to pop all higher precedence operators and then push the current element into the stack. Current operator will be pushed into the stack. Okay? And then after we access all the tokens, the complete expression, this for loop is over, then you have to copy remaining operators from OP stack, all the operators from OP stack, and copy it into P stack. Okay? All the operators will be popped from OP stack and pushed into the pre stack. And then finally pop everything from pre stack. Okay, pop everything from pre stack and create your prefix expression. Okay, I equal to 0 and prefix of I plus plus. Here we are copying each and every character and finally appending /0 to it. Okay, so if we do the conversion, option 2, we are getting the share complete screen. So for the same expression, we are getting this as prefix. So if we check your prefix, no, it is wrong, I think. Some of the condition is not matching. Expression is it is not giving the correct answer. Maybe some of the condition is not correct. Okay, but I will rectify and I will show you the updated code in the next. But as the algorithm is clear, you can go with that algorithm. Okay, you can start writing the conversion algorithm.